Okay. So welcome. My name is Godwin Morris, and I am based in New York City, and I run a makerspace and what I call a STEM education center. So I have two physical facilities in Manhattan on the Upper West Side, if you know where that is. One is a classroom space, we call it Dazzling Discoveries, and the other is Skill Mill NYC, and that's what we call our makerspace. That's where the laser cutter is, the 3D printers, sewing machines, vinyl cutter. And we use both spaces. They're one block apart, and we use both spaces a little bit interchangeably. We do teacher workshops, we do school visits, we do after school classes, we do camp groups, and we kind of have a younger, older category, but we do a lot of teaching. I've been doing this for 20 years, before Makerspace was a word, before STEM was a word. The Makerspace is newer, but the Dazzling Discoveries piece, the hands-on engineering and science, I've been doing for 20 years. So over that time, I invented a couple of products. One is a cardboard engineering kit that we sell. You can't get it on Amazon. We're the only ones who have it. Just so you see that, it's called Dazzlings. And then over the 20 years, I've been using paper primarily as my starting point engineering material. And so actually just before the pandemic, we started to think about making some of that information available to teachers. And then it was just a perfect match for the pandemic because you could make things at home, kids could make things at home, teachers could guide them. So we went into overdrive and created a whole series of packets that we call Engineering with Paper. And that's actually our trademarked name. So that's what I'm going to talk about today and show you how that works. And it still works in classrooms. It's more fun to do in person. It does still work virtually. So the idea behind all of that was that over my 20 plus years of working with kids, what I found was that kids are sometimes resistant to doing things, even hands-on things, and it's mostly because they don't know how to use the materials. And so that usually means they don't know how to get started. And if you've ever had a kid say, I don't want to do this, my experience has been 99% of the time, it means I don't know how to do this. And because I don't know how, I'm scared, and therefore I don't want to. So we've taken that concept and broken it down into very accessible, easy to use steps and materials to break through that resistance. I also have teachers who say that. So just that idea, when you don't know how to do something, it's scary, and we want to make it less scary. The premise behind all of this is also to begin with what we call core skills. So teachers come to every experience with some prior knowledge. Some kids have more prior knowledge than others, and that's the problem. So you will have a few kids who maybe have an architect for a parent, or have been to a whole bunch of science museums, or just get more gifts as construction material toys. They know how to build, or they know how to attach things. But I'm not concerned about those kids. They obviously have a track of information coming on in their lives. I focus on the kids who don't have that, the kids who look at materials and just literally don't know how to use them. And so what we want to do is give everybody some basic core skills. You would never ask somebody to build a real bridge without them going to engineering school. And in engineering school, they're going to learn the math, they're going to learn the material science, they're going to learn physics, they're going to learn some information that they can use to then design a bridge. And that's the idea here. What can we give them in advance to help them get started? Just a quick, during the pandemic, New York Times was publishing weekly projects, how to make things out of newspaper. And they liked our projects and actually published 4 of our projects in the New York Times. We were thrilled to have this happen. This is the course of between 20 and 2021. It was about a year, spread out over a year or so. So we are published authors. This is me and my assistant director, Paula Frisch. We're published authors in the New York Times. You can find us by searching my name. Okay, so engineering with paper is the idea of using just paper, tape, scissors to make any kind of project. A couple kinds of projects. It can apply, just as we're talking about makerspace resources, the same thing. These projects can apply to any topic. This is so on our website we have several free projects, and we do charge for some of them because these are very detailed packets of how to fold things, and so it just cost us a lot of time and money to produce them. But we do have several free ones, and the catapult is probably our most popular of anything, and it is definitely a free project. So I'm going to just show you some of the kinds of projects, and as you look at this, you'll see a repeating pattern of similar shapes. The idea behind engineering with paper is you're using basic shapes as building blocks, cylinders, tracks. This project uses just cylinder track, cylinder shape, and the track shape. This is our parachute. And again, paper, strips of paper. It's all about cutting and folding paper into simple material shapes, simple pieces, and then folding them in specific ways. I'm just going to flip through these. So just so you get an idea of what's involved with these kinds of projects and how versatile they are. And again, they're using the same shapes. So the base, those pink bases, that is the same shape as the Ferris wheel sections. This creature. This is our hat project. This is we recommend rolling paper into tubes or straws and building with them. Simple marionette. And these all come in bundles. You see on the right side, we group them, or we sell them separately. And they're a few dollars. These are definitely inexpensive. This is the project I'm going to focus on today, which is our balance beam. And so when we do lessons in our programs, and again, we're after school and camp, we're not a classroom, but we do a lot of classroom style work. So I often like to start with real images and show kids what the topic is in the real world before we then build our model. So I'm just going to flip through some pictures that I have here. These are all from the internet, or actually I took this one because there's a great circus in New York City called the Big Apple Circus. And this is literally a balancing act. It's a little hard to tell. He's actually standing on cylinders. It's not a column. It was anyway. So, but most of these pictures are from the real world, and you can get them off the internet. So I just go through what are all the ways where in our lives do we come in contact with balance. And of course we experience a balance, or we interact. Balance is part of every single minute of our life because we're standing up. It's obvious, but we'll go through some of the more extreme or the more interesting ones. And again, I just put these slides together to show students, to get them thinking, to make them realize how this fits into their lives. This one, I do this one because I like to use this. This happens to be my family. Toys, a lot of balance in toys. There's a lot of balance in art. You can go into a whole study of Alexander Calder, who was actually an engineer before he became a sculptor and an artist. And so the difference between these two is this one is hanging. So it's balancing off of a vertical coming down. And then this one is underneath, balancing on top of something. And then you can go into the science of balance. What is balance? How does it work? What do forces mean? Again, I'm showing you the kinds of things that we cover. We don't always cover all of this in full detail. Sometimes you can do this just as an art project. If you want to go into the science or the math of it, this lesson happens to have an excellent math component too. So, oops, sorry. So these are just, I'm not going to go into the science of balance right now. I'm just covering the basic topics, center of mass. And I think most of you know that concept. It moves around depending on where the heaviest part of an object is. The basic principle of balance is that you're always balancing on something. There's always a point of contact. So if I'm in New York, so subways and buses, people standing wobble more than when they're sitting because when you're sitting, your heaviest part of your body is around your hips. And when that's in direct contact with the seat, you're more stable. So this just shows you that. So the hammer on the right will fall over, but if you were standing it up straight and that heavier part at the top were in line with the blue line where it was hitting the base, you could actually balance it. So it's just keeping the weight over at the center of the contact. And then not everything is centered. Balance is not actually a visual, but when we do it in schools, or and when we think about it, we often think of it because the word, in a way, and when you balance an equation, it has to be equal on both sides. So in those cases, balance is even, but in an object, it's not a visual experience. It's a weight experience. You can feel it, but you can't always see it. And so the center of gravity on this hammer will be much closer to the heavier part. Okay. So just quick, any questions on that point before I go in and show you how to actually make your own balance project? I can't see the chat, so let me know if there's anything in the chat.
No questions in the chat right now. Okay.
All right. So I'm going to show you how to use paper. It could be the copy paper. We design all these projects to work with copy paper. Some of them work a little bit better with a little bit stiffer manila folder paper, but in this case, copy paper. So if you want to build along, and you can grab a couple of pieces of scrap paper, old magazine pages, whatever you have handy, tape and scissors. I know that you didn't come prepared for this part, so probably you don't have that handy, but I'm just going to chat for a second. So if you want to go grab it, you can. And otherwise it'll be on this recording and you can come back and look at it. Okay. So you can see, I'm going to show you a few pictures of finished projects, and then I'm going to show you how we actually build this. And these are clearly students working with the finished project. And here's the idea. And you'll notice that you can make different kinds of weights that you can add to this project. So this particular one has, and again, we're moving it out. It's not centered because now you have more weight on one side. And there is definitely a creative element to making the pieces you would add to this. So for engineering with paper, as I said, everything is made with paper, tape, scissors. That's all you need. Sometimes we have actually one of our free downloads is what we call a cutting guide, because in my classroom, I find it's helpful to pre-cut paper into different sizes. For this particular project, we need full sheets of paper for every part of it, but some of them having smaller pieces. All right, so the very first thing we find is helpful is first teaching kids how to use tape, but also teaching them how to cut it into small pieces. We attach it to, often to a plastic container. So here, if you can see me in the little box, you know, these food containers, any kind of plastic container, we find is very helpful, particularly when you hold it upside down. In the video, we used a ceramic cup just because it shows it up pretty well. But the idea is it's very helpful to pre-rip the tape. And one of the challenges that teachers have in general is projects are easy to do if one person is doing them. But when you try to do it with a group of children, there are some characteristics or some techniques that make that group experience much smoother. This is one of them. Having the kids, I have kids sometimes will put it just on the edge of their desks, right in front of them, but I give them a long strip and a pair of scissors, and we show them how to cut it. Everybody likes to rip the tape. It seems faster, and that works too. You just get ragged edges. And if you touch tape too often, it loses its stickiness. So I like it if I can get the kids to learn to cut pieces themselves, but you can also rip it. For the younger kids, we pre-rip it. For sometimes the kindergartners and first graders have a little trouble with this. Actually, sometimes the seventh graders have a little trouble with this too. It's about motor skills more than anything else. So it's good to practice cutting tape. Okay. So now I'm going to show you a couple of videos that we produce about how to do this. This one is just going to show you all the pieces of this project. So it's a flat piece of paper with the edges folded up. It's a second piece, and then I'm going to show you how to make each of these sections. The second piece is the track, and then the third and fourth are rings. You can make more than 2 rings. And then this is the balance beam piece that supports the whole project. Okay, can you see? Are we back on Make the Sticks page? I just want to make sure you're seeing what I'm seeing. Somebody just give me.
Yes, make the sticks.
Okay. Okay, so here's the video on how to actually make the sticks, and I'm going to speed this up a little bit because we don't have a huge amount of time. So again, full sheets of paper, and it's just a lot of folding. The main thing we talk about is the size of the paper. We do not use hot dog and hamburger references. That is it just not everybody knows what that means. So we use longer and shorter sides, edges actually, the edges of the paper. So this is holding the paper horizontally and just folding it over 3 times from the shorter edge to the shorter edge. I'm going to show it, it's going to come up again because you need to make 2 sticks. So the second version, you can see this again. So again, shorter sides of the paper. We have longer and shorter, shorter, shorter. Fold them, match the corners. Fold it once. Fold it a second time. And then fold it a third time. And this makes the paper stiffer. And now you have paper sticks. Just taping them so it stays closed, and then you have 2 paper sticks. Now you want to make them into connect them at the tip. So you just line them up, and you're making kind of a hinge piece by just taping over the top of it. And there you go. And that's what you're going to use as your balance support. Okay, now we're going to go back to, now we'll make the base. This one's pretty quick. Again, full sheet of paper. Again, the shorter edges and the longer edges. And in this case, you just fold about an inch, inch and a half, 2 inches. You want it on each side of the paper. And that works as the base. That's also, and I'll show you the next video, will show you that's similar to the way we make the track, just make it more narrow. And many of these shapes are used over and over. We use paper sticks for many things. We use this track shape in so many of the projects. So again, full sheet, shorter edges are on the sides, it's horizontal. You're folding longer edge to longer edge. Line up the corners. Fold it in half. Always rub that folded edge so you get a nice crease. Fold it again. And now, so again, that's similar to the stick, but we're not folding it completely again. Now we're just folding up the edges similar to that base, but not as wide. So it's about 1/2 inch. It's pretty forgiving. It doesn't have to be exact. Now this will significantly stiffen the paper. You just put a little bit of tape on it to keep it together. So that's now the track. Okay, and we're gonna make the loops. And again, another full sheet of paper, because you need the full sheet of paper for the loops, because you need the mass. And you can experiment. This is definitely an area where you can experiment with the students on trying different quantities, different types of paper, different quantities of paper. So again, it's the same system. You're taking the longer edge, folding it in half, then folding it in half again. And in this case, we're going to fold it a 3rd time, similar to the paper stick that we made earlier. And then you can take this, and you particularly need copy paper, soft paper. You can roll it into a loop. Now, it will actually fit you can actually fit one edge of the loop into the other edge. In this case, we didn't do it in the video, we just used tape, but you could connect it just by sliding it as well. And so we're just taping the loop so it stays closed. You can test different size loops. And you do not have to make loops. We generally make a loop for the first one, but after that you can make, just take the stick and fold it in different ways and hang it from the inside of the loop. I think we had that in one of the earlier photos. And again, you need to make at least 2 loops. We have a lot of projects with 3 loops. You could also have the students experiment with folding the paper shorter edge to shorter edge a few times and seeing how it will make a smaller circle, but it's still the same mass. So it's a great extension. And we find that this is a particularly popular project with math teachers, because you're measuring and testing some math concepts in this. So again, we're just folding paper. This works best with copy paper or any kind of soft paper, because you need it to be flexible enough to roll and to fold. And there we have the loops. Okay, so now this is the final short piece of this. These are the components that you now have. That's the base. You've got your track. You've got your loops. You have your balance support or balance point. And what you're going to do is just tape, that's the stick. Whoops. So you can see this. This is, now this one we use 2 loops on one side and one on the other, but the idea is you just take that stick and you just literally tape it inside the folded edges. And then you put your balance arm on top and start playing. And here's an example of some creative projects that students came up with. The one on the top left, they made baskets so that they could put other things in for the balance beam. The one on the bottom shows everything on one side. This is a pretty forgiving project in terms of the logistics of it, so that the track piece also works if it's upside down the other way. It doesn't have to be facing up that way. It goes both ways. But once everybody makes this, then you can take this and extend it in any way that's useful. And again, it's paper, so it has a lot of flexibility, both in the paper and with what you can do with it. This is just a balanced project with our Dazzlinks, same idea. This is also our Dazzlinks kits. And then this is our engineering with paper overview. These are many of the packets. And what I can show you from this picture is how the shapes repeat, which is really the point. We want you to learn how to make some basic shapes and then just use them over and over. And once you teach them to the kids, they start to understand how they can use them again and again. So, for example, in that upper left corner, the Simple Machines has a picture of the catapult. You obviously will recognize the track piece is in there. That catapult uses just two shapes, a cylinder and a track piece. And again, the catapult, not the Simple Machines, but the catapult, which is on the bottom right corner of the screen, is a free download. So please get that, use it, try it. The track piece is also in the playground as a slide. It's in the roller coaster. It's in the gravitational forces, which bundle, which is what we're using right now. It just the idea is some really basic shapes. In this, actually, I think it's also on the Be Anything hat, I think it's also the nose. And so across these pictures, you'll see that there's rectangular prisms in several projects. There's paper straws, which can be used over and over. The mini house uses what we call our paper tray, which is also the base of the habitat. And the paper tray can be made into a base, but if you make it small, it can be a refrigerator or a bunk bed or a swimming pool, or just, it was used in the balance project to make the two baskets. Lots of options. So the idea across all of the engineering with paper methodology is a few basic shapes that can be used over and over in different ways. And once you teach those shapes to the kids and then give them challenges, they know what to do. They know how to get started. Let me just see what else I have here. So this is our Instagram. Follow us on Instagram, Twitter. We have a Facebook group, all of that. We have here's the Facebook group if anybody wants to participate and join us for that. So are there any questions? How much more time do we have?
We have 15 minutes left.
15 minutes. Oh, okay.
Yeah.
Oh, because we started. Okay. I had it in my head that it was at 2. So we have all of that. I did a workshop actually yesterday in New Orleans at the Fetch conference. And what we did with that one was, I'm going to stop sharing for a minute and show you something else. So the idea was the engineer. Oh, great. Oh, Krista, nice to see you. Thanks for, oh, good. You made the, here, right. Let me just spotlight you. Oops, can we spotlight Krista for a minute? Ivan, can you do that, or should
Unfortunately, I cannot do the spotlight. But
okay.
If anyone wants to see Chris does, you can make pin on her.
So thanks, Krista. That was great, and it's nice to see you. We haven't talked for a little while, so. So there are dozens of things you can make with paper, and the idea is that you can then take this as a way to get started, and then kids can build things out of cardboard, and then they can take these same ideas and use them for Tinkercad or 3D modeling. But if you start kids with paper, yeah, I'll put the Facebook group in. You can start them thinking about shapes, and it just gives you an easy way to get started with physical manipulations, and then it makes a much easier transition to Tinkercad when you're trying to do 3D models. And sometimes we have kids make a physical thing using these shapes and then going to Tinkercad and pulling out the shapes. And then there's another program that I found recently called Shapegrams. I don't know, has anybody seen that one? It's really very pretty. I'm going to show, let's see. Let me, let me just see if I can, I'm going to get this, it's going to take me a quick second to just put it up on my screen. I just think it's just a, and again, they have shapegrams.com. So what they do is they use the Google shapes. So if you're in Google Slides, everybody knows all of these shapes, and then they combine them to make images. And so I often like to use this as another way to teach kids about spatial reasoning, which is a lot of what we're talking about in most of the sessions that I do. Spatial reasoning has come up as a great way to help children do problem solving and more creative thinking, and that the ability to think in either 3 dimensions or just that basic box, 3-dimensional box, and a whole pile of things, and how do you get them into that box? Those are all skills that are very transferable in life and in work. And so Shapegrams takes the 3-dimensional concept and brings it down to the 2-dimensional visuals. Let's see if we can look at some of their projects. So they have these little drawing challenges of how do you make, and you can see at the bottom they're coded for yeah, I'm not sure I think if we go to look at this, it's just going to make a copy, right? So I can't show you, but you can go to Shapegrams and look at them yourself. And the idea is that it takes these things and breaks down. Oh, I was hoping that they must have an example of it somewhere. Anyway, go to Shapegrams and see what they do. And then the other one that we'll take a look at is whoops. I assume most of you know Tinkercad. It's the 3D modeling, since we're all from the maker world. It's the easiest and best 3D modeling software for kids to use and adults too. It's gotten more and more sophisticated over the years. When we teach it in our program, we do not let the kids use the pre-existing models. We make everybody design their own project because they're not learning anything when they download the, so even this kind of thing. But this shows you how it's taking, again, it's about making shapes. So this is a perfect example of, you could have kids try to design their own airplane or car or something with paper shapes and then reproduce it in Tinkercad or in Shapegrams or out of cardboard or in any other material that you want to use. You can even use it with a combination of supplies. All right, so we're going to stop sharing and check in and see if we've got anything. And I see my friends here, and we've done roller coasters. We just did some projects at school in New York City. We did with Karen, who's on the Zoom. We did our roller coaster project online during Zoom with 100 students, and we had everybody making roller coasters out of paper. Karen's somewhere on my Instagram. There's a picture of you showing that. So any questions? We've got a few more minutes, so I just wanted to
thank you again. That was fun. It's always a nice reminder that paper is a powerful tool. Paper is a powerful tool. I'm always amazed how interesting and complex concepts can be presented with really simple shapes and simple materials. So thank you so much for the reminder.
The other thing that's fun is that, and Karen, I'm going to call on you again because you made that lamp out of go ahead, explain what you did. Because the idea is that you get different kinds of paper and you also get a lot of junk mail. And
I did. Last summer, 2 summers ago, there were like 35 people running for New York City mayor. And so for the Democratic primary race, I should say. And so all the mailings I was sent, I had a hard time. You can't really recycle some of that glossy paper. So I just saved it thinking I would do a project. And then I ended up rolling each one of those rectangular flyers into a tube. This was after the roller coaster projects. I was thinking about tubes of paper. And then I put them in a cylindrical shape, and they're all different lengths. It's in the space upstairs, but I'm in my office. And yeah, and then I stuck an IKEA corded light bulb through the middle, so it's a hanging lamp. I'll try and find a picture on my phone, which is never going to happen.
but she just took the tubes and then attached them all, and then that it made its own material, and then curved them into a sort of a cylinder in itself. So that's another thing that we do. You can take a pencil, you can take paper and just roll it up into tubes, and it doesn't matter how wide they are, and you can attach them and kids build with them. Then to have a more consistent building material, we take a pencil and roll the paper around pencils so that we create paper straws and then attach those. Kids love to make those. I highly recommend it. You definitely need soft paper for that one. And the other thing we do is we use a lot of recycled materials. So all the catalogs, all the mailings, whatever you get. I was just, again, as I said earlier, I was at a conference yesterday, an educator conference, and in the exhibit hall, everybody's got paper they're giving out. And so I went around and collected different kinds and then used it in my workshop. So you get the stiffer paper, that oak tag, manila folder paper, and you get, and even cereal box cardboard, which is a little tricky to roll, but it has a grain. So if you test it, you can figure out where the grain is in that. And then just copy paper, whatever you have as your extra paper. So I think, did you find it? Okay. So can you share your screen? No, but you can, if you just hold it up. Oh,
I actually just found a link online, so I'm just going to share the link online.
Okay, put it in the chat.
Copy link address. Hey, Krista, it's so nice to see your face too. There, so it's like a post I wrote about it.
Okay, I'm gonna just put that up.
Unless that's not it. I actually don't know.
Well, I'm just gonna put up your.
Whoops. Okay, I don't really love. I'm very tired right now. Oh yeah, share screen. I don't even remember where it is.
Oh, that's beautiful.
Thanks.
I didn't realize the posters were so big. It
was so annoying. I found it. You're exactly right. Thank you, Godwin, for always encouraging me to do something that makes sense. So yeah, they sent me like all these flyers from all these candidates, and I was finally just rolling them into tubes, not even knowing what I would do. And then I made a cylinder out of some Amazon boxes. And then just glued them on, and there's my light.
Right now.
Yeah, that's it. And actually, it's not an ideal lamp. I was thinking I need to cut out some like holes around the edge, the sides to let some light shine out, but whatever, it's good enough.
Well, and that same shape could be used as a garbage container. Like you can make your own paper recycling containers or a planter, or it doesn't have to necessarily be a hanging lamp.
Yeah,
the concept works.
Just repurposing materials. I'm trying to, it's like reduce, reuse, recycle. I'm trying to refuse to make it into refuse, and then we have to repurpose. We can't just keep throwing things out or expecting it to be recycled, because people don't really recycle. So if we could just repurpose supplies as much as possible and get as much use out of them as possible before we consider what to do after they're fully used up. That's important.
And we get so much paper, and it's so easy to reuse it for things. So I think
we still have a few minutes, 2-3 minutes. If we have some more questions from the audience? If not, I can ask one. I'm curious to know if you offer any kind of pedagogical support to teachers, meaning some set of guidelines on which subjects they could use your material, to which age, which standards, these kind of things that are also important for teachers. I mean, how they adapt what you are providing and they can use it in their classes as official, I mean, in formal education.
Yes, so on our, here, wait, I have Karen's up here, but let me just show you on our Dazzling Discoveries website, which is, I have to give you the, we break everything down by age, by, here, where are they? Let's see. Oh, this is all of them, sorry. All right, dazzlingdiscoveries.com has the projects here. So we have it by grade level. We have it by, and then within this, it talks about what you can do. We don't get involved in standards specifically because the idea of this is that you can use it to make projects that relate to whatever you're teaching. And so the standards are really up to the teacher. It just, so if you're studying bridges, you can make a paper bridge. If you're studying force and motion, if you're studying balance, the idea of this is to give you some of the projects that you might want to do with this. That's the idea behind all of that. So again, so this is our dazzlingdiscoveries.com website. And that's where you'll find all the information. That's where the free downloads are. That's where all of our projects are.
I think it's like Legos, Godwin, like any age, right? Age 8 to forever or whatever it is. Anyone can make cool stuff with this and just make them more and more complex as you gain more knowledge.
Right. And we've done it with 4-year-olds and we've done it with 15-year-olds. The paper straws are great for middle school and high school kids, and and some of the simpler shapes are good for the younger kids. So that's really the idea. Let's see. Here's what we've got. It's like our hat, and these are the ones that are good for the younger kids. And it goes on and on. All right. I think we're done. Let me stop sharing. There's Karen again. Okay.
Do we have any more questions? Yeah, sorry.
Probably no more questions, but I'm sure people will watch this video. So feel free to get in touch with me at dazzlingdiscoveries.com, info@dazzlingdiscoveries.com. I think we're good on that. So here's this page. So that's the Facebook group. It's facebook.com/group STEM engine. It's STEM Engineering with Paper. Somebody had asked about the Facebook group. And there's our contact information. That's always a good screen to end on. So thank you for watching.
Thank you. I would like to show you that I was also following the.
Oh, great. Oh, thanks. And isn't it? It's fun. It's a fun.
Yeah, it's really fun. It's really fun.
Yeah, it's way more fun than it sounds.
Yeah, I think that always working with your hands is fun. I mean, whatever you can do with hands is always a rewarding experience.
That is for sure. So,
okay.
Right,
Thank you very much. Thank you very much.